35. Well, today we'll take a look at if we have polynomial denominators, how can we start finding that least common multiple? Because we're still going to have, they're technically not numbers down there, but we still have some polynomials, and we're going to talk about how do you find the least common multiple dealing with these polynomials. So first, we're going to start with just monomial. So monomial means that each of these denominators only has one term. That's it. So we have an 8x and we have an 11x. When we are looking at polynomials, we are going to look at the factors. So what makes up this polynomial? Well, the factors of this polynomial are an 8 and an x. The factors of this polynomial are an 11 and an x. So we look at what makes up the polynomial. We're looking at its factors. With numbers, we can kind of use multiplying multiples to figure out that least common denominator. With polynomials, we have to use the factors. Now, the next thing you look for is you look for what are all the different possible factors that I have between my two denominators. So as I look through, I've got an 8, and then I would check, do I have any other 8s in my factors? I do not, so 8 is going to be part of my LCM. Then I look, I have an x. So I look, is there any other x's? And there is. If you ever have two of the exact same thing, we only need to take one of those to build our LCM. So 8 and x are going to be part of our LCM. And then lastly, I have an 11. So an 11 is different. So I look at all my factors. So I factor it out. I've got 8x, 11x. Those are all four of my factors. And I pick out where are all my different factors. If we have a common factor, that's going to cause a common multiple, which we don't need that common factor. So that's why I crossed this one out. So we don't need that one. Now we can start finding our LCM. And to find the LCM, you just multiply those factors that are left, and we're left with an LCM of 88x. So our LCM here would be 88x. So to recap, we start by looking at the numbers. What are the factors of those numbers, 8 and 11? And then we look at the x. And I have a little trick when we get into delta math, we'll see. So there's a little trick that goes with monomials that makes it pretty simple. And really what you're doing with the 8 and the 11 is you're still doing that multiplying out and figuring out, okay, it meets at 88 is when the 8 and 11 are going to meet up. And then with the variables, I got a little trick as well. So we'll get to that when we get to the delta math problem. Part B, find the least common denominator of the two rational expressions. So again, the denominators are the only thing we're focused on. So we're looking at those two trinomials. Now, when we're trying to build our LCM, we are looking at the factors. So I do need to factor both of these denominators. So I'm going to get all four factors laid out, and then I'm going to look again to build my LCM. I'm going to look at how can I, or where are all my different factors that I'm dealing with. So since I have a trinomial with a term 1, I know that this is going to be x and x. And now I'm looking at that little number riddle. How could I multiply to negative 35 and then add to negative 2? Well, that would be negative 7 and positive 5. So those would be my two factors that create the multiplying to negative 35 and then add to negative 2. So with these trinomials, and hopefully you had a chance to practice those yesterday in delta math, the trinomials, you're always looking to multiply to that last number, add to that middle term, and that's going to be your two numbers that it factors into. Second one, we need to multiply to negative 5 and then add to 4. Well, 5, there's only one way to multiply to it, 1 and 5. And then which one would have to be positive? It'd have to be the 5. So x plus 5 and x minus 1 would be my two factors. So I've got x plus 5, x minus 1 for that second fractions denominator. So it took me a little longer than the first problem because the first problem was just monomials and I could just split up the two numbers. But I've ultimately got now everything factored out. Now here's where we start to build our LCM. And when you build the LCM, you look for where are all my different factors. So the LCM, when you start multiplying out those factors, the LCM is going to just be created from all those different factors. So here I look, I've got an x minus 7, and I would just check through, are there any other x minus 7s? No, so x minus 7, that's going to be part of my LCM. Then I look, I got an x plus 5, and I would check my other factors. Do I have an x plus 5? I do, so I only need to take one of those. We don't need to take multiple of the same one. So I got x plus 5. And then lastly, I've got another factor here, x minus 1, and that's the only factor of x minus 1, so that's going to be my last factor. So those are my three different factors, and those are going to be what creates that LCM. So there's my LCM, and we are actually just going to leave it as factored form. That's fine. X minus 7, x plus 5, x minus 1, that's going to be my LCM. So we are building onto bigger and greater things. So right now we're just kind of barely scratching the surface, but eventually these values, those denominators, they're going to start to mean certain things when you graph these problems. But for right now, we're just looking at how can I build that LCM. Heading down, we're just going to take a look at one last example, and here's where I have that little trick that we can do. So now we're going to get into how we can add two rational expressions. So we look at our two fractions that we're dealing with, and they're not the same denominator. So I do need to get a common denominator. So I look, I've got a 4 and an x to the 5th on this one. And then over here, I've got a 12 and then an x to the 3rd. So this is kind of like my 8 and 11 from above. So 4 and 12, I think about 4 and 12, when are they first going to meet up with each other? Well, they're going to meet up at 12. So 12 would be the first time that when you multiply out 4, 8, 12, that they're going to meet each other. Next, we have variables. Now, I do have the exact same letter in my variable parts, but the powers are different. This is x to the 5th, or 5x is x times x times x times x. This is x to the 3rd, which is x times x times x, 3 x's. Well, when is the first time they're going to meet? Well, the first time they're going to meet is if I would multiply out another x and another x, that would meet at x to the 5th. So if I would multiply out 2 more x's, that would mean I would meet at x to the 5th. So the trick is with these variables, you're always just going to take the highest degree because they're eventually going to meet at a certain power, and it's always going to meet at the highest degree. So just like the 4s, when we multiplied out the 4s, they would meet at 12. That's when they would be common. The variables are going to meet always at that highest degree. So we'd have a 12x to the 5th plus 12x to the 5th. So those are going to be my two denominators. And just like yesterday, just kind of relating it back to when we're adding like pieces of pizza, we're adding those, we have to have the exact same size pieces or else it's not going to make any sense. Now the second piece is we got to make equivalent fractions. So if I look at this first denominator, I had 4x to the 5th. Now I've got 12x to the 5th. So what did I do to my denominator to get to 12x to the 5th? I multiplied it by 3. And I have to do the same thing to my numerator then. So that's going to be 9 over 12x to the 5th. Next, I have a 7 over 12x to the 3rd. So to get 12x to the 3rd to change to x to the 5th, I multiplied by x squared. I got to multiply my numerator by x squared. And that's going to be 7x squared. Then I can now add those together. My answer, remember from yesterday, your answer is still going to have the exact same denominator. And then your numerator would be 9 plus 7x squared. And since x squared is a different term than the 9, so the constant and then a variable, we can't combine those together, but we can get our final result will be 9 plus 7x squared over 12x to the 5th. So that's about as far as we're going in our Delta Math practice today. And I want to just head over quickly to Delta Math and just take a look at a couple example problems. And remember, I am recording this, so everything we'll be able to revisit later on. So here's an example of a Delta Math problem. We got 2x over 5 minus 7x over 9. Problem is 5 and 9 are different denominators, so we need to create a common denominator. So we'll create a denominator of 45. So 45 will be the first time that 9 and 5 will meet. Now you think to yourself, what did I do to 5 to get to 45? I multiplied it by 9. So I got to do that to the numerator. That would make 18x. In my numerator, I've got a 7x. What did I do to the 9 to get 45? I multiplied it by 5. So that would make this 35x. And 18x minus 35x is going to bring me down into the negatives, negative 17x over 45. So if we have that different denominator, we can find the common denominator. Then we have to adjust our numerators based on how we changed our denominators. Now to type this in, I can hit negative 17x, hit the fraction bar, hit 45, and they're going to also go through the work that we just did. So find that common denominator of 45, multiply your numerators and denominators, or they call them tops and bottoms, multiply your tops and bottoms by that. Secondly, we'll look at some that have variable denominators. So looking at my denominators in this problem, I've got an 8x, and then I've got an 8x squared. So this one is made up of 8 and x. This one's made up of 8 and x squared. So the 8, all right, the 8 is going to be part of my common denominator. And then anytime I have a variable, I'm going to take the one with the higher degree, because eventually if I multiply out x's, it's going to meet at x squared. So I'm going to take out the higher degree. So x squared is going to be part of my denominator. Now the first fraction, we take 8x and make it 8x squared. So we multiplied our denominator by x. We have to multiply our numerator by x. Or they're going to say you multiplied your bottom by x, you got to multiply your top by x. The second fraction, we actually don't even change. So that one's just going to stay the same. Final answer then is 5x plus 3 over 8x squared. Sorry, my mouse is getting a little shaky there. 5x plus 3 over 8x squared. Now to type this in, you do have to be a little careful. If we have a binomial in our fraction, we do have to put that in parentheses so it groups it all together, and then when you hit fraction bar, it'll keep it all up in the numerator, and then we can type in 8x squared. So there would be our final result. And you can see that they just multiplied their tops and bottoms by x, just like we did, and they're going to walk through the problem there for you. So I'm going to leave it at that. I will stick around for the rest of the hour for extra help. You are free to break off to work on your own. I'll post this video. So if you want to go back and